This is National 5 Relationships Unit Assessment and it's practice, and what we're looking at is the Assessment Standard 1.4, and that's the geometry type questions that we're going to be looking at here. The questions will be question 13, 14, 15 and 16, and throughout there we've got 8 marks that we need to go through, and 4 marks would be what you need to achieve to pass the outcome. Right, so let's start on question 13. Question 13, we've got a couple of shapes here. Are these shapes rectangles? Sometimes when you do this type of question you may get it being a screen of some sort, maybe a room, and what it's asking for is to state whether it's a rectangle. So basically, are these shapes rectangles? For this type of work, what I'd need to do is I'd need to be thinking about seeing if the angle down here is a right angle. So what I'm going to be using is Pythagoras theorem, but because I know all of the sides, what I'm going to do is I'm going to use the converse of Pythagoras to work this out. So what I'm going to do first of all is I'm going to work out the shorter sides, okay? And what I'm going to do is I'm going to square them. So I've got 1.9 squared plus 0.6 squared, so that's the two shorter sides, and I'm going to work out what that's going to be. So on the calculator that would tell me that's 3.97 meters. I'll then work out the longer side, which is the hypotenuse, so the longest side, and I'm going to do these separately when I do it. So it's 2.0 squared, and that's going to give me an answer of 4 coming out there. Okay, so then what I'm going to be doing is I'm going to compare these two values here and see if they're the same. And I'll make a statement. So what I'll say is that since I've got 1.9 squared plus 0.6 squared, they're not equal. They're pretty close, but they're not equal. So does not equal the 2.0 squared. I'm going to say by the converse of Pythagoras, Pythagoras theorem. So by the converse of Pythagoras theorem, the triangle that I'm looking at there, so the triangle is not right angled. So if it's not right angled, that corner that's there, I would then go on to say, and therefore the shape is not a rectangle. Okay, so for marking this type of question here, what I'm going to get is I'm going to get 1 mark for squaring the shorter sides and evaluating that. I'll get 1 mark here for squaring the longest side and evaluating that part, and it's only these 2 marks that count towards the standard 1.4. This mark here with the statement, okay, this statement here will go towards the mark, I think it's 2.2 that's going to go for, and that will be 1 mark in the 2.2 standard, and that's because it's one of these interpreting the results type questions, answers. This part here, I've got 1 mark there, 1 mark there, so in this question here I'm looking to gain 2 marks towards the standard 1.4, 1 mark towards 2.2. Right then, so have a go at the rest of these and see how you go. Here's the solutions. So the shorter sides, so I've got 1.5 squared plus 2.0 squared, and what I'll do is I'll get an answer for that. That's going to be 6.25. I'll then do the longest side. The longest side will be 2.5 squared, and again, good, that's equal to 6.25. So this type of statement here will be a more positive statement, because since 1.5 squared plus 2.0 squared equals 2.5 squared, so it does equal it by the converse of Pythagoras theorem. the triangle is right angled, and therefore the shape is a rectangle. Okay. So again, that would be the marks for that one there. There's only one of these questions in the NAB, so you know, it might be one or the other. It might be a one that is positive, that does work out correctly, and one that doesn't. Okay, let's look at the last one here. Look at the shorter sides. And what we'll do is we'll just square both of these, and plus 7.1 squared, and that should work out to be 621.62. Okay, so let's look at the longest side, and let's work that one through. So the longest side is 24.9 squared, and what that is equal to is 620.01. So yeah, they're very, very close, but if they're not exact, then it's not a right angle. So again, statement would be, since we've got 23.9 squared plus 7.1 squared does not equal the 24.9 squared, by the converse of Pythagoras theorem, the triangle, so that would be the triangle that I'm looking at, this triangle here is not right angled, and if that's not right angled, the shape is not a rectangle. Okay, so there we go. So we've got 2 marks that we're going to be looking for there. Right, let's move on to question 14. Question 14 will be something to do with angles. It may be something like what I have here, some of these types of examples, or it may be just slightly different, but what you'd have to do is use your knowledge of angles and your geometry to try and work out the missing angles. Right, so the diagrams show kites, so there's our kites that are there, where AB and AD are tangents to the circle. So if I know it's a tangent, then the first thing that I know is that that there is a right angle. That there is a right angle there. So given the size of angle BCD, so BCD, so that angle there, calculate the angle BAD. So the one that I'm interested in is the size of this angle here. Right, so what I'll do to work that angle out, I know that the angles in a quadrilateral should be adding up to 360 degrees. So what I'll do is I'll add up the value of the angles that I have already. So I know that that's 90 degrees there, so I'll go for 90 plus the 90 plus the 138, and what that should give me is, add that together, 318 degrees. What I'll then do is I'll take the 360 degrees and I'll subtract the 318 degrees from that, and from there what I should get is the angle which is BAD, and that should be giving me 42 degrees. Okay. So as far as marking on this question here, what we really should be getting is, I think we'll get 1 mark for either stating that that angle or that angle is 90 degrees. So having a 90 degrees there would be pretty good. The next mark would be for subtracting this value here from 360, knowing to do that, and the final mark for stating the angle that we need. So that's going to be out of 3 marks. Let's do the same with part B. Okay, so it's a tangent, it's going to be at 90 degrees, so these are 90 degrees there. So if I add on 90 plus 90, and I'll add on the angle that I'm given, that should give me a value of 309. Okay. So the 360 for the quadrilateral subtracting the 309, that should give me the angle that I'm looking for, and the angle is BAD. So angle BAD is going to be equal to, and that's 51 degrees. So that'll be 3 marks that would look like that. Right, so let's go on to 14C, and again, I know that if that's a tangent will meet here, especially when that's the centre of the circle, meet it at right angles. So 90 plus 90 plus 141 will give me 321. I'll subtract 321 from the 360, and what that should leave me with is the angle that I'm after, angle BAD, is going to be equal to 39 degrees. Okay, so that's out of 3 marks for question 14. Let's look at 15. Right, still on the geometry theme. What I have here is from the information given for these similar shapes. So there's one of the keywords that I'm looking at, similar. So that'll be similarity section that I'm going to be looking at here. Calculate the missing volume or area as appropriate. Okay, so let's have a look at this question first here. So what I've got is I've got a large kind of cuboid. I've got the length of one of the sides, and I've got the volume of the cuboid, so it's a volume question. I've got a smaller one here, so it's kind of shrunk in size, 5 centimetres, and I've got to work out the volume. So with this type of question, what we've always got to do is to work out the scale factor. So remember, the scale factor is equal to the new over the old. And I always see the new as being the one that I'm trying to work out. So this will be the new one here. So for the scale factor, the thing that I know that kind of aligns with each other would be the 5 and the 25. And simplifying that down would be 1 over 5. So that's the scale factor. Now the new volume is going to be equal to the scale factor that I've just worked out, and because it's volume, I'm going to cube that scale factor and multiply it by the old volume, or the volume that I know. So the scale factor cubed times the old volume, which is 875, and if I put that into the calculator, what I should get out there is 7 centimetres cubed. Okay, so all I need to do is to put that into the calculator, either using the fraction or open bracket 1 divided by 5 close bracket cubed times 875, and I should get the new volume. So that's considerably lower, so you must remember to use the scale factor cubed when we're working with volume. Let's see how that one's going to be marked there. So what we've got, first of all, we're just going to get 1 mark for this part here. So that would be working out the scale factor, cubing it, and also multiplying it by the old volume. So that's everything there. And then 1 mark for making sure that we can get the correct answer out of our calculators for that there. It doesn't have to be 1 over 5 that's there, it could go in as 5 over 25, so there's no need to simplify that in the marking scheme here. Okay, so 2 marks would be for question 15. Let's look at the next question. So have a try at the next 2 questions and see how you get on. Here's the solution. So first of all, get the scale factor, and it's the new divided by the old. So what we're going for is, this is the old one, this is the new one. I've got 6 over 18. That'll simplify down to a third. I don't need to simplify it, remember, I'm just going to do that for myself. This one here is working on area, so what we'll look at is the new area is equal to the scale factor, and remember the scale factor squared for area, not cubed, and we multiply that by the old area. Right, so scale factor squared, so that's going to be 1 over 3, and I'm going to square that, multiply that by the old area, which is 58.5. So 1 over 3 cubed will be a 9th, so I'm going to divide that by 9, or just fire the whole thing into the calculator, and I should get out 6.5 centimetres, and remember, with it being area, the units will be centimetres squared. Last one here, it's a volume question again, so let's work out our scale factor first. new over old. So the new one's the one I'm trying to find something out about. So I'm going to go for 15 over 20. Can leave it like that, or I could simplify it down to 3 over 4, just by dividing by 5. I'll work out the new volume, and I'll work that out by cubing the scale factor and multiplying it by the volume of the old. Okay, so that's the old. So that's the old volume. Okay. So if I put that all into the working, I'll get 3 over 4 cubed times 1920, and into the calculator with that, and that'll go 810, and that's going to be centimetres cubed for the volume. Okay, so that's that question complete as well. Right then, so the last question in this section is question 16. And what we have in question 16 here is we've defined the size of these shaded areas. Okay, the shaded area, that's an interior angle. And the way I'm going to go about each of these questions is the same, just using different numbers based on the shape that I've been given. Right, let's start for this shape here. And the first thing that I'm going to do there is I'm going to try and work out the angle that's in at the centre here. So this is the first thing that I'm going to do. I'm going to work that out. So I know that the number of sides on this one here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's a 10-sided shape. So to work out the angle, so the angle at the centre would be 360 degrees. I'll divide that by the number of sides I've got, or the number of triangles that I've made up there. So that there is going to give me 36 degrees that's there. From that, what I'll do is I know that this angle here is 36 degrees now. To find the angles at the bottom, what I'll do is I'll subtract that number from 180. So 180 minus 36, and what that should give me will be 144. And what I'll do is I'll divide that number by 2 to get the angles down here. So that's 72, 72. If I know there's 72, I know this one's 72, this one's 72 as well. But for that angle there, it would be, so the shaded area, or the shaded angle, is going to be equal to 72 plus 72, which equals 144 degrees. Right, for marking this one here, what we've got is we'll have one mark. So there's only one mark here that will go towards the 1.4 assessment standard, and it's really going to be just getting the answer that's there. So that's going to be out of one mark for this part. There is one other mark that we'll get, and it's going to be for this part here. And this part here is going to go towards the mark for standard 2.2, no, 2.1. That'll be 2.1. The reason for that is because it's a strategy type question, so it's the way that we've tried to work out a strategy for solving this problem. So 1 for that, but certainly for the 1.4 assessment standard, that's where you're going to get your mark for just getting the final answer. Okay, let's go and do the next two that are here. So same model that I'm going to follow. I'm going to work out the angle at the centre. So this angle here I'm going to work out first of all. So 360 divided by how many sides it is. So I've got 1, 2, 3, 4, 5, 6, 7, 8. Divide that by 8 and I should get 45 degrees. I'll work out the other angles down here by subtracting 45 from 180. I get 135, and then divide 135 by 2 to find out the angles at the bottom. So that angle there would be 67.5 degrees. So 67.5, 67.5. This one here would also be 67.5. So I know that the shaded angle is going to be equal to 67.5 plus 67.5, which is just this value that's here, which gives me 135 35 degrees. The final question in this section here will be 360 divided by how many sides there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's a 9-sided shape, so let's go for that. So 360 divided by 9 will give me 40 degrees. From the 40 degrees, I'm going to substitute that from 180, which leaves 140 degrees. So 140 divided by 2 gives me 70 degrees. So in here I've got 40 degrees, in here I've got 70, in here I've got 70, 70 in there. So the shaded angle is equal to 2 70s, which gives me 140 degrees. So remember here we've got 1 mark that's for section 2.1, 1 mark here for the assessment standard 1.4. Okay, so remember here that you require 8 marks in this geometry section. There's 8 marks given here. You need 4 of them to be successful in this outcome. Good luck.